Today we will discuss mechanical properties of solids. Okay. So we know that solid क्या होता है, रिजिड होता है. सॉलिड क्या होता है, रिजिड होता है, राइट. अब कुछ सॉलिड क्या होता है कि कुछ सॉलिड टाइट होता है और कुछ सॉलिड क्या होता है, ब्रिटल होता है. जैसे कि हम जानते हैं कि जो भी मेटल है आपके सारे मेटल क्या होता है, उसमें डक्टिलिटी की प्रॉपर्टी होती है. और जो भी नॉन मेटल है, नॉन मेटल क्या होता है, नॉन मेटल सारे नॉन मेटल क्या होता है, ब्रिटल होता है, राइट. सो ये जो डक्टिलिटी की प्रॉपर्टी है, यहाँ से हमें क्या मिलता है, इलास्टिसिटी का जो कॉन्सेप्ट है वो हमें मिलता है यहाँ से, राइट. सो जो भी आपका मेटल होगा, मेटल क्या होगा, मेटल में आपका इलास्टिसिटी बिहेवियर होगा. मेटल्स में क्या होगा, इलास्टिसिटी बिहेवियर एग्जिस्ट करेगा, राइट. कुछ सारे मेटल होगा. एक मेटल है जो कि आपका मरकरी है. मरकरी क्या होता है, वो रूम टेम्परेचर इसमें होता है, लिक्विड स्टेट में होता है, राइट. सो मरकरी की बात नहीं करेंगे. और गैलियम भी है. गैलियम भी रूम टेम्परेचर से स्लाइट एबव जाने पर क्या होता है, वो लिक्विड स्टेट में आ जाता है. तो हम मरकरी और गैलियम की बात नहीं करेंगे, राइट. और जो भी आपका नॉन मेटल है वो क्या होता है, नॉन मेटल आपका ब्रिटल होता है. तो नॉन मेटल में अगर आप फोर्स लगाइएगा, कोई डिफॉर्मिंग फोर्स लगाइएगा, तो वो क्या होगा, आपका डिफॉर्मिंग फोर्स जब लगाइएगा तो वो क्या होगा, ब्रिटल होगा. तो नॉन मेटल में क्या होगा, ये प्रॉपर्टी आपका एग्जिस्ट नहीं करेगा. सो फर्स्ट हम जानते हैं कि इलास्टिसिटी क्या होता है, इलास्टिसिटी एंड व्हाट इज इलास्टिसिटी. सो वी विल डिस्कस फर्स्ट अबाउट व्हाट इलास्टिसिटी. सो इलास्टिसिटी, व्हाट इज इलास्टिसिटी, राइट. इलास्टिसिटी द property to restore the property to restore the natural shape, the property to restore the natural shape or to oppose the deformation, Okay. To oppose the deformation is called what? Is called elasticity. Is called elasticity. Okay. प्रॉपर्टी टू रिस्टोर यानी कि दोनों प्रॉपर्टी होना चाहिए. यानी कि इलास्टिसिटी का क्या होगा आपका, कि वो अपने नेचुरल शेप को क्या करे, वो रिस्टोर भी करे. और जैसे कि रबर है, रबर में आपने क्या किया कि डिफॉर्मिंग फोर्स आपने लगाया और उसको आपने स्ट्रेच किया, राइट. तो वो क्या हुआ, वो स्ट्रेच हुआ, राइट. और फिर आफ्टर दैट क्या होगा, अगर आप डिफॉर्मिंग फोर्स आपने जैसे हटाया वो क्या होगा, अपने नेचुरल शेप में आ जाएगा, राइट. सो एक तो ये होगा कि अपने वो रिस्टोर करेगा वो किसको, अपने नेचुरल शेप को. और क्या है कि अपोज भी करेगा, टू अपोज द डिफॉर्मेशन फोर्सेस, राइट. आप अगर ये फोर्स आपने जो लगाया था, राइट, तो वो क्या होगा कि उसमें आपने ज़्यादा फोर्स लगाया तो वो क्या होगा, स्ट्रेच हुआ. लेकिन एक फोर्स है जो रिस्टोरिंग फोर्स है, वो क्या करता है, उसको क्या कर रहा है, वो अपोज भी कर रहा होता है, राइट. बट फोर्स आपने क्या क्या ज़्यादा लगाया, जिसकी वजह से उसमें क्या होगा, चेंजेस आएगा, डिफॉर्मेशन होगा, राइट. सो क्या करेगा, वो जो बॉडी है वो क्या करेगा, उस फोर्स को क्या करेगा, अपोज भी करेगा, राइट. सो ये आपका इलास्टिसिटी का क्या है, डेफिनेशन है. The property to restore the natural shape or to oppose the deformation is called elasticity. Okay, example आप ले लीजिए. Example rubber, steel, iron, aluminium, etc. Okay. And now we know what is perfectly elasticity and what is plasticity. So if a body gains natural shape after removing of deforming forces, then it is called what? Perfectly elastic body. And if a body, okay, what would be called plastic body? Okay, if a body gains its natural shape, if a body gains its natural shape after removal of what? After removal of deforming forces. After removal of deforming forces, then it is elasticity, perfectly elastic. Okay, and if our body remains if our body remains in deformed state, if our body remains in deformed state or does not even partially gains its original or you can say natural its original state after removal of deforming forces then it is called perfectly inelastic or plastic metal. इलास्टिक और प्लास्टिक बॉडी मीन्स अगर किसी भी बॉडी पे क्या आपने फोर्स लगाया और फोर्स लगाने पे क्या हुआ उसमें कि वो अपने शेप में जैसा फोर्स लगाया उसी शेप में वो क्या हुआ रहा, तो वो क्या होगा आपका परफेक्टली इनइलास्टिक या प्लास्टिक बॉडी होगा, राइट। इलास्टिसिटी के बाद हम लोग डिस्कस करेंगे स्ट्रेस एंड स्ट्रेन। सो नाउ वी विल फर्स्ट डिस्कस अबाउट व्हाट स्ट्रेस। ओके, सो व्हाट इज स्ट्रेस? Stress is defined as the internal restoring forces, okay, force per unit cross sectional area. Okay, internal restoring force per unit cross sectional area, and stress is denoted by what? Stress is denoted by the letter what? Sigma. Okay, sigma, right? So in mathematically we can write what? Stress sigma equal to what? Restoring force per unit area. Okay, this force will be what? Restoring force. Okay, Fr. Okay, so sigma equal to Fr upon A, restoring force per unit area. One will be if we apply a force on this rod. Okay, we apply force. This is a force external, and this will be force external. Okay, so due to this force, the body internal molecules will get a force that will be called what? Restoring force, and due to this force, the body will get what? Restoring force. So stress will be what? Restoring force per unit cross sectional area. So this cross sectional area will be unit cross sectional area will be taken care. Okay, so now we know stress. Okay, now we will discuss about types of stress. Okay, so types of stress, there are mainly two types of stress. We will discuss about that. Okay, types of stress. Okay, one will be called what? Normal stress, and the other one will be called what? Tangential stress. Or tangential stress stress is also known as what? Shearing stress. Shearing stress. Okay. Normal stress is also of two types. One will be called what? Longitudinal stress. Longitudinal stress, and the other one will be called what? Volume stress. Volume stress, right? And longitudinal stress will be also of two types. Okay. One will be called what? Tensile stress, and second one will be called compressive stress. Compressive stress. Okay. So, what is longitudinal stress and what is tangential stress and what is volume stress and tensile and compressive stress, right? Okay. So, in longitudinal stress, there are two types of stress: tensile stress and compressive stress. So, example of what is tensile stress? If I have a rod, then if we apply a force F external, okay, F external, then due to this, okay, F reduced volume and F reduced volume. So if we apply a force at the bottom with equal and opposite forces, then it is called what? Tensile stress and compressive stress. If we push at the bottoms with equal and opposite forces, then it is called what? Compressive stress, right? So in longitudinal stress, why it is called longitudinal? Because force is applied perpendicular to cross section. That's why this is called longitudinal stress. And in longitudinal stress, there are two types of tensile and compressive. So one force will be what? At the bottom means we pull, and other one will be what? At the bottoms we push the force. So that will be called what? Compressive stress, and other one will be called what? Tensile stress. In volume stress, if a solid body immerses in a what? Liquid. So due to liquid, the force is applied on this body. Okay. So what force? This is a normal force, right? Act on a body perpendicularly. Okay. So here this stress is called what? Pressure. Okay. There stress and pressure will be equal, right? So in volume stress also, volume stress sigma V equal to what? F upon A. Okay. Compressive stress also sigma equal to F R upon A. Okay. Tensile stress same, sigma equal to F R upon A. Okay. And in tangential stress, okay, if a body is fixed, at one point, and we apply a force what? Not perpendicular, tangentially. Okay. If we apply force tangentially, then what will happen? So like this, and this one will become like this. So here the change in it will be like this one, this type of change. Okay, will occur. So tangential stress will be what? Force will apply what? Tangentially, not perpendicularly. So tangential stress or shearing stress will be sigma T equal to what? F R upon A. Okay. So this is all type of stress here. Okay, we discuss normal stress and tangential stress and types of normal stress. There are two types of normal stress: longitudinal stress and volume stress, right? And longitudinal, there are two types of also longitudinal stress: tensile stress and compressive stress. Okay. So if we discuss about strain, now we will discuss about strain. Okay. So what is strain? Okay. Strain. If strain is defined, strain is defined as change in dimension. Change in dimension due to what? Due to stress. Change in dimension due to stress to the original dimension. Okay. So in mathematically, strain is denoted as epsilon. Change in dimension divided by original dimension. Okay. So strain is also three types of strain we will see. Okay. One will be what? Longitudinal strain and longitudinal strain, and second one will be what? Shearing strain. Shearing strain is also known as what? Tangential strain. Okay. And third one will be what? Volume strain. Right? So now we will first discuss about longitudinal strain. If a body is fixed at one, okay, so if we apply a force, this is original length. Okay, if we apply a force, then this rod will get some changes in this rod. Okay, so these changes will occur length, and this will change in length. Okay, so change from here to here. Okay, so here strain will be epsilon will be what? Longitudinal. Change in length upon original length. Right? In tangential stress or shearing strain, if a body fixed at one point and then we apply a tangential force, then what change will occur? Like this. Okay. So this is the original length, and here change this is del x. Okay. So here we will take this length. Okay, changing length upon original length. So here epsilon will be what? Del x upon L. Okay. So here shearing strain will be what? Del x change in this length and upon original length. Okay. In volume strain, okay, solid will be immersed in what? Liquid. And force will apply to this liquid. Okay. Then what type of changes will occur? So here epsilon equal to what? Change in volume. Here volume will reduce like this one. Okay. This volume will happen like this one. Okay. So what will get? Change in volume upon original volume. So here volume strain will be what? Change in volume upon original volume. Okay. So there are three types of strain we discuss, and if we discuss strain and strain, there is a relation between stress and strain. Okay.